Hi. So today, me and my team are going to talk about heart disease prediction, and my team includes myself, Anurag, Raaz, and Shiny. Next slide. So heart disease remains one of the leading causes of death globally, and early detection is crucial for saving a lot of lives. The goal of this project is to try and create a predictive model for heart disease using big data and advanced analytics. Our motivation stems from the immense data driven tools to enhance clinical decision making by identifying patterns in medical data or and using this data we can provide to doctors to make actionable and quick insights into a patient which can go on to save a patient's life. Next slide. Data, to give you a quick overview of the data set is used for used for this project contains a range of variables which includes patient demographics, medical test results, and risk factors. Before the analysis, the data went through processing, for cleaning of data, which included removing missing values and removing the outliers as well to ensure it was suitable for modeling. The foundation was essential to ensure, the accuracy and the predictability of the model. So to tell you guys about the data overview, we got the data set from Kaggle, which is a UCI heart disease data set. The main features of this data set is age, sex, that is gender, cholesterol, blood pressure, etc. There are a total of 14 attributes in the data set. And the target variable is the presence of heart disease, which is a binary value that is 1 for true and 0 for false. Next. For project scope, we use the CRISP DM methodology for the framework, that is the understanding the data, data preparation, modeling, and then evaluation. And then for the implementation, we use PySpark for scalability and efficiency. Methodology, our main three methods were logistic regression. This is the baseline model for interpretable but limited for capturing non-linear relationships. And then we used decision trees effective for non-linear patterns. And then finally, we have random forest, which is an ensemble method for robust, for it gives you robust results and avoids overfitting, and it also has the best performance.
So now we're going to be talking about the feature importance of random forest. Random forest is a predictive model which uses a lot of decision trees to make the predictions regarding the target variable, which is heart diseases in our case. And feature importance measures how much each feature contributes towards the heart diseases. As you can see from the chart, chest pain type index is the most significant factor indicating that specific types of chest pain are the strong indicators of heart disease later in their lives. And something like fasting blood sugar index, it shows that it's not very much contributing towards the heart diseases. And some more features like vessels colored by fluoroscopy index and thalassemia index, old peak. These are some of the most contributing factors towards the heart diseases. And moving on to the next slide. So now we're going to be looking at probability distribution of all our models. And to start with, probability distribution measures it shows us the distribution of how the predictions are spread across the cases. As we can see here for logistic regression, there are some cases of clear predictions and some uncertain predictions. When we look at the clear predictions, we are talking about the 0 and 1, which have a very high frequency. And the middle spectrum of the chart is uncertain predictions because of the fewer cases lying in there. And the overall probability distribution shows that the demonstrates the ability to make predictive decisions. So now we are going to be talking about the probability distribution of decision trees. Decision trees is a model which splits the data set into different branches, and it makes the predictions based on the majority class of the branch. And as we can see here, based on the chart here, we have some clear classifications and some low ambiguity classifications. The clear classifications are the ones with the highest frequencies. Again, as we can see, it's with 0 and 1. 0 meaning the person is very unlikely to get a heart disease, and 1 being he is almost likely to get a heart disease. And there's some ambiguity in the mid range because it's not as frequent as the others. And the strength in simplicity is that decision trees handle non-linear patterns effectively, providing intuitive classifications. Next. So now we're going to be talking about the probability distribution of the random forest. Random forest combines multiple decision trees, so we can see a smoother mid-range in the chart. And we also see like before we see better results in 0 and 1, which makes it pretty easier for doctors and other users to analyze the charts. And most clear classification, majority of predictions are strongly confident, and they are concentrated on the extremes of probability. And this combines multiple decision trees to improve prediction robustness and reduce. Okay, so now let's talk about the evaluation matrix. For the evaluation, we have used two things, accuracy and AUC. AUC is basically area under the curve. So for accuracy, the accuracy tells how well the model is performing, and AUC will tell whether a person will get a heart disease or not. So based on the random forest, we got an accuracy of 90%, which is really good for a data set. And we got an AUC of 0.972, which is again a good number. Uh, which is again a good number. So now let's talk about business suggestion. Based on our models, we have certain suggestions. Firstly, we can integrate this model in hospitals, clinical tools. This will help doctors to understand what. This will help doctors to evaluate and have early diagnosis of the disease, which will eventually help save a lot of life. Second, we can focus on the key risk factors like chest pain or things that can give heart disease in the early stage. Again, this will help save a lot of life because we know in today's time, heart disease or heart attack is one of the main causes of death. Third is scalability. So we are working not with a very huge data set, but a huge data set can be used, or a real life data set can be used to make models, to make even better models and even better prediction. Fourthly, we can use this model to have a specific tailored program for a specific person like if a person has high chances of heart disease, so what kind of diet he should follow, what kind of exercise he should follow, and so on and so forth. Lastly, we can incorporate this model for different demographics and with real-time data, as I said in earlier point as well. Next.
Conclude, out of all the models that we used, Random Forest gave the most accurate result with an accuracy of 90%. This is because in the Random Forest we use multiple decision trees which gave us the highest accuracy and highest AUC. Now let's talk about the significance of our project. As we worked with the healthcare data set, it's just not a model. It's about the impact that this model produces on the lives of the people. With this insight, we can create tools to aid early diagnosis, monitor critical factors, and design personalized interventions to save and improve patients' life in the early stages itself and detect their heart conditions. So that was all about the insights and whatever findings we found in the project. Thank you.